Guten Tag to all you physics students out there. Today's topic is on projectile motion, and I hope that you all have your coloured pens ready to go to take some notes, so we'll get straight underway. Alright, so first of all, projectile motion is when an object moves freely through a uniform field. So first of all, we have to think about what a uniform field is. So a field or uniform field is a region of space where a constant force is acting in a particular direction. So one example of a uniform field is a gravitational field. So when we're looking at gravity, we're looking at a force that's acting between actually every single object in the universe that has mass. Every object, for example, that table there and that chair there, will actually have a gravitational force between them. And it's an invisible force, we can't see it, but we can feel the effects of it. Alright, so we can all know that gravity exists, but how much is the force is determined by what's known as the universal law of gravitation. So that's summarised very simply by this formula. Okay, so M1 might be the first mass, measured in kilograms, and M2 is the second mass, also in kilograms. And the amount of force that is experienced between these two objects depends on the size of the two masses, but also the distance that they are apart. So we measure the distance from the centre to the centre, and we call that R. Alright? And gravity is what we call an inverse square relationship. So that means that as the distance doubles, the force is going to get weaker, but it's not half as much force. It's actually 1/4 because of the R squared component here. Now you might ask, well, what's this thing here? Well, this is called the universal gravitational constant, and it has a value of 6.67 times 10 to the minus 11. And essentially that number helps give an answer for the force in the units that we're familiar with. So is everyone familiar with the units of force? They are correct, newtons. Alright, so if we want to have an understanding of how much the force is, then we need this constant here so that our answer will be given in newtons and we can compare it to any other force we might be familiar with. Okay, so force of gravity acts on both objects. It's a mutual force, but if mass 2 is smaller, then that's going to be accelerated towards the larger mass more than the other mass is going to be accelerated the other way. So if you think about this very carefully, you might see that if we draw the force lines for gravity around the first mass, you might see something, because we're talking about motion in a uniform field. So a uniform field is when, as I said before, the force is constant. It's always acting in a particular direction and it's constant. Now, with this particular example, you might be able to see, well, if we're out here as compared to here, the force is going to change. So strictly speaking, this field is not 100% constant. But what we do is, when we're on the Earth's surface, the Earth is so massive, if I throw a ball a few hundred meters, if I could, then we can actually consider that the force is pretty much uniform. All right? So we'll come back to that later.